Plastic is a petroleum-based material. It doesn't biodegrade. Instead, it breaks down into micro and nanoplastic particles. Nanoplastic particles are so tiny that they are even smaller than viruses. When they enter the water, these particles disrupt its orderly structure, which is based on hydrogen bonds between molecules. These bonds define water's key properties, and any disruption to them alters the physical and chemical characteristics of water. Nanoparticles of certain types of plastic, such as polyethylene terephthalate, PET, and nylon, contain oxygen and nitrogen atoms. These atoms can form hydrogen bonds directly with water molecules. As a result, such particles integrate into water's ordered structure, altering its organization and disrupting its fundamental properties. Moreover, in aqueous solutions containing various substances, as well as under changes in pH and temperature, nanoplastic particles can become electrically charged. This occurs due to chemical changes on their surface, such as oxidation, or through the adsorption of ions, like sodium and chloride, in seawater. Charged nanoplastic particles surrounded by ions attract water molecules, forming a multi-layered coat of water molecules around them. In chemical terms, this process is known as hydration, and the coat is referred to as a hydration shell. Researchers from the Federal Polytechnic School of Lausanne sought to determine the size of this hydration shell around ions, that is, how many water molecules respond to an ion. They arrived at astonishing results. It turns out that a single ion can influence approximately 1 million surrounding water molecules. This effect is amplified if the particle has a large surface charge and a high concentration of adsorbed ions. Consequently, a single nanoplastic particle can alter the properties of millions of water molecules. Molecules bound within the hydration shell are less mobile, which reduces their contribution to the overall heat capacity of water. In other words, such water heats up faster under the same external conditions and cools down more quickly compared to pure water. Moreover, the disrupted hydrogen bond structure around nanoplastics lowers water's thermal conductivity. This implies that water near nanoplastics can be warmer due to a reduced ability to dissipate heat. In this way, nanoplastic actively interacts not only with ions and impurities present in the water, but also with water molecules themselves, altering the hydrogen bond network that defines water's key properties. As a result, both the heat capacity and thermal conductivity of water change. This leads to an overall increase in temperature and contributes to the heating of the entire ocean. It is important to note that even a small amount of nanoplastics can have a profound effect on water properties. This underscores the need for further research and an assessment of nanoplastic concentrations in various aquatic environments to fully understand its impact.